Good day everyone. So last time we have dealt with the introduction for our subject, statistics and probability. At this point, we will be dealing with random variables and probability distribution. For today's discussion, you are expected to illustrate a random variable, be it a discrete or continuous, distinguish between a discrete and a continuous variable, find the possible values of a random variable, and illustrate a probability distribution for a discrete random variable and its properties. Random variables and probability distributions are important concepts in statistics and probability. When we do an experiment, we are not only interested in the values that a random variable can assume, but also with the probabilities associated with these values. When we say random variable, it is a variable whose possible values are determined by chance. It is typically represented by an uppercase letter, usually x, while its corresponding lowercase letter, in this case x, is used to represent one of its values. The study of random variables in this unit exposes us to some very interesting real-world problems on probability. Let's have our first example. A coin is tossed twice. Let the variable x represent the number of heads that result from this experiment. Now take a look with this illustration. Random variable is represented by the uppercase x, this one. The lowercase x represents the specific values. Hence, x could be 0, 1, or 2. So as you can see, the sample space for the possible outcome is we have head-head, head-tail, tail-head, or tail-tail. So the value of the variable x can be 0, 1, or 2. Random variables can either be discrete or continuous. When we say discrete random variable, it can only take a finite or countable number of distinct values. Distinct values mean values that are exact and can be represented by non-negative whole numbers. Here are the following examples of discrete random variables. Let's take the first one. Let x be the number of students randomly selected to be interviewed by a researcher. So this is a discrete random variable because its possible values are 0, it can be 0, 1, 2, and so on. The same is true with the second one. The number of left-handed teachers randomly selected in a faculty room. So this is also a discrete random variable. And lastly, we have let z, the number of defective light bulbs among the randomly selected light bulbs. So this is a discrete random variable because the number of defective light bulbs, which is y, or z rather, can assume are 0, 1, 2, and so on. Did you get it now? We now come with continuous random variable. It is defined as a variable that can assume an infinite number of values in an interval between two specific values. These values are often results of measurement. A continuous random variable can assume values that can be represented not only by non-negative whole numbers, but also by fractions and decimals. Let's have the following examples. Let y be the weights of randomly selected students in kilograms. So this is a continuous random variable because its values can be between any two given weights. Also, weights are measured using a weighing scale. The weight of a student, for example, can be 60.5 kilograms, but due to limits of measuring devices, the measurement is always an approximate. So the weights of students can range from 60 to 61 kilograms, including all the decimal places that come between these two values. Also, for the second example, let x be the length of randomly selected shoes of students in centimeters. The lengths of shoes of the students can be between any two given lengths. The values can be obtained by using a measuring device or a ruler. Hence, the random variable x is a continuous random variable. So as you can see, these are results of measurement, or often results of measurement. Now let's have some sample exercises. Determine if the random variable x or y is discrete or continuous. So we'll be discussing the answers for this exercise in our virtual class. For letter A, let x be the number of points scored in the last season by a randomly selected basketball player in the PBA. Letter B, let y be the height of a randomly selected student inside the library. Letter C, let x be the weights in kilogram of randomly selected dancers after taking up aerobics. And letter D, let y be the number of birds in a nest. So identify if the given random variable x or y is discrete or continuous. Now we are done illustrating a random variable, be it a discrete or a continuous variable. Now let's proceed with discrete probability distribution. When we say discrete probability distribution, it is a listing of possible values of a discrete random variable along with their corresponding probabilities. The discrete probability distribution can be presented in tabular, graphical, or formula form. The following properties must be satisfied before a distribution can be considered a discrete probability distribution. The first property, the probability of each value of a discrete random variable is between 0 and 1 inclusive. That is, in symbol we have the probability must be greater than or equal to 0 but less than or equal to 1. And the second property that must be satisfied is the sum of all the probabilities must be equal to 1. Is that clear? Consider the following table. So in this table, the random variable x assumes the values 0, 1, 2, and 3. The corresponding probabilities of these values are 0.2, 0.3, 0.3, and 0.2 respectively. So these corresponding probabilities are each less than 1 but greater than 0. And when added, the sum is equal to 1. So as you can see, the two properties were being met. So this is a discrete probability distribution. If we're going to add the corresponding probabilities, we have 0.2, 0.3, 0.3, and 0.2, we'll get 1. Okay? Let's have another example. The given spinner is divided into 4 sections. Let x be the score where the arrow will stop, numbered as 1, 2, 3, and 4. So find the probability that the arrow will stop at 1, 2, 3, and 4. And construct the discrete probability distribution of the random variable x. Okay, let's have letter A. Let x be the score on the spinner. So the probability that the arrow will stop at any of the 4 divisions is 1 out of 4, or 1/4. Or in decimal, we have 0.25. Hence, the probability of landing on 1 is 1/4, 1 out of 4, also with the probability of landing on 2, 3, and 4. So they have the same probabilities. Okay, for letter B, a table similar to the following can be constructed to show the values assumed by the discrete random variable x and its corresponding probabilities. So the discrete probability distribution is presented in tabular form in this slide. So we have the following x, we have values for x 1, 2, 3, and 4, and their corresponding probabilities we have 1/4, 1/4, 1/4, and 1/4. So the first property is met. Each of the probabilities is greater than 0 but less than 1. O, kasi nga diba 1/4 is equivalent to 0.25. So that is greater than 0 but less than 1. And if we're going to add them up, the sum is equal to 1. Therefore, the two requirements for a discrete probability distribution are satisfied. So this is a discrete probability distribution. Did you get it now? Okay, it's your turn. Practice answering the following. So we'll discuss this one during our virtual class. The spinner is divided into 8 sections. Let X be the score where the arrow will stop, numbered as 1, 2, 3, and 4. Find the probability that the arrow will stop at 1, 2, 3, and 4, and construct the discrete probability distribution of the random variable X. So we're going to construct a table showing the probability distribution and test if the two properties will be satisfied. Okay? Okay. So how about if we have the following? So a discrete random variable X has the following probability distribution. So we have for X we have 0, 1, 2, 3, and 4. And for the corresponding probabilities we have 0 0.1, 0 0.2. For the probability at 2, at X is 2 is unknown. And for 3, X is 3, 0 0.2, and 4, 0 0.2. Now determine what is the probability if X is equal to 2. So we have the following solution. In determining what is being unknown, so we will be using the second property in which we're going to add all the given probabilities and it must be equal to 1. So equate that into 1. So we have 1 here. The sum must be equal to 1 if that is equal to the corresponding probabilities. So we have 0.1 plus 0.2 plus the unknown plus 0.2 plus 0.2. So add them up. So we'll get 1 is equal to 0.7 plus the probability if X is 2. And then we'll subtract it. 1 minus 0.7 will get 0.3. Okay, let's have the second one. How about if we have the following? A random variable X has the following probability distribution. So determine C and the probability if X is equal to 2. So the same thing. You can use, we will use the second property. So we have 1 is equal to the given probabilities. And then combine like terms. And then isolate the one with variable. And you'll get the following. So 1 less 0.71, that is 0.29 is equal to 29C. Divide both sides by 29. Therefore, C is equal to 0.01. And the probability if X is 2 is equal to 0.29. If we're going to add that to the given probabilities, the sum will be equal to 1. Therefore, it is a discrete probability distribution. For your questions, prepare them if you have, and you may raise them during our virtual class. See you and stay safe.